Hi, my name is William Sellier. I did the Green Mars, Deploy Greenhouse with Simon Rose over there. Our objective was to deploy an automated and self-deploying greenhouse on a Martian landscape as an advanced life support system. Now, I'm showing you a concept diagram here because we actually don't know really what this thing would look like. We have some assumptions on energy losses. We looked at the basic parameters for plant growth, and we expanded from there and see if we could make these systems feasible with the technology that we have. So the basic needs and the project parameters are we need 50 meters squared growing area per person. So we're just assuming this is a single person greenhouse for the moment. 600 watts per meter squared for photosynthesis. And for optimal plant growth, we need humidity at 70%, temperature at 26.6 degrees Celsius, and certain partial pressures for CO2 and O2. With these, we've discovered that we can operate at 28 kilopascals, which is definitely hypobaric compared to atmospheric pressure, but we know that plant growth can occur at temperatures as low as, or pressures as low as 20 kilopascals. So the major problems we've encountered was that 600 watts per meter squared times 50 meters squared is a lot of energy. We don't know how to heat the greenhouse. Well, we didn't. How do you maintain humidity? And traditional growth media, such as soil or water for hydroponic gardens, is extremely heavy. But we have solutions. Instead of hydroponics or soil, we're using aeroponics. So the plant is suspended in the air, and a nutrition-rich solution is sprayed onto the roots. What we did for this is we generated an octagonal greenhouse with an area of 50 meters squared with pipes running. And these pipes have holes in them, so when you put a pressure or put a solution through them, it percolates out and it can achieve the root. What we did in order to put a plant on there is we took a geotextile with the plants already ingrained in it, which we can lay on top. And that way we can also remove it once the plants are grown, and we can put in a new one for the next crop season. Radiation energy required. We've managed to reduce 600 watts per meter squared to 260 watts per meter squared by selecting only wavelengths which are required for photosynthesis. There's two very narrow bands in the spectrum required for this. We've talked with a plant physiologist at NASA, and he did say that this was possible. Nuclear power. Solar panels would not work. There's just not enough space. So we've done some literature review, and we found that advanced Stirling radioisotope generators are capable of approximately 15 kilowatts. However, we found a NASA press release where they found a small suitcase nuclear generator at 40 kilowatts. We asked them for specs. They denied. They actually laughed at us. Anyway, 40 kilowatts is a lot of energy, but this has a lot of benefits. We can use waste energy to vaporize water and control temperature within the greenhouse. And forcing water over the heat exchange within the greenhouse will also provide circulation required for plant growth. We have looked and built control systems and flow diagrams for the different solutions. We found that we can completely close the water loop. We can extract CO2 from the Martian atmosphere if required. And we have to figure out still how to extract oxygen if we have manned missions there. These are our estimated specs. The two things worth noting is that, or three things, we're well under our energy limits. We have 1.6 tons total mass, and a 9 diameter radius for our greenhouse is not even a problem for the Saturn V. So we know we can launch this. Thank you.